Hello, this is FASTECH. Prior to the detailed product description, let me briefly introduce the FASTECH Ethernet product line and Ethernet total solution. Here is a brand called Ezi-SERVO. Ezi-SERVO is a closed-loop stepping system product line. And there is a brand called Ezi-STEPII. Ezi-STEPII is an open-loop micro-stepping system product line. And there is a brand called Ezi-MOTIONLINK. Ezi-MOTIONLINK is a one-axis motion controller for AC servo drive. Lastly, the brand Ezi-IO is an I/O module product line including digital I/O module, analog I/O module, and high-speed counter module. So, FASTECH Ethernet product line has the Ezi-SERVO brand of the closed-loop stepping system, the Ezi-STEPII brand of the open-loop micro-stepping system, the Ezi-MOTIONLINK brand of the one-axis motion controller for AC servo drive. These three product series have built-in motion controller and the Ezi-IO brand of the I/O module. Let's take a look at each product brand one by one. First, Ezi-SERVO brand. Ezi-SERVO brand has three products including Ezi-SERVO 2+E, a standard type of closed-loop stepping system, Ezi-SERVO 2+E Mini, a mini drive type, and Ezi-SERVO 2+E All, an all-in-one type that combines a motor, a high-resolution encoder, a drive, a motion controller and Ethernet network. Next, Ezi-STEPII brand. Ezi-STEPII brand has three products including Ezi-STEPII 2+E, a standard type of open-loop micro-stepping system, Ezi-STEPII 2+E Mini, a mini drive type, and Ezi-STEPII 2+E All, an all-in-one type that combines a motor, a drive, a motion controller and Ethernet network. Next, Ezi-MOTIONLINK brand. Ezi-MOTIONLINK brand has one product called Ezi-MOTIONLINK +E, a one-axis motion controller that can be directly connected to various AC servos such as Yaskawa and Mitsubishi. Finally, Ezi-IO brand. Ezi-IO brand has four products including Ezi-IO Ethernet DIO, a digital I/O module, Ezi-IO Ethernet AD, an analog input module, Ezi-IO Ethernet DA, an analog output module, and Ezi-IO Ethernet CNT, a high-speed counter module. So, FASTECH has a total of 11 Ethernet products. Since there are various types of products, we can provide a total solution that enables stepping motor, AC servo, and I/O module to be controlled through the standard Ethernet port of a PC without a separate motion controller. This is the meaning of total solutions. Until now, I briefly introduced the meaning of the total solution and FASTECH's Ethernet products. Among 11 types of products, I'd like to introduce the high-speed counter module, Ezi-IO Ethernet CNT. Next, before introducing Ezi-IO Ethernet CNT, I would like to explain the FASTECH's Ethernet products with the example of Korean market situation. When a customer configures the machine, PC or PLC is used in various ways as the main master. In the Korean market, this main master is an industrial PC usually. Almost 70 to 80% of them compose their machine based on PC. The main reason is that the software development environment is flexible when controlling machine. That is, accessibility is good. In more detail, since customers can easily configure machine programs in a Windows-based programming environment by directly connecting to a Windows-based PC, most customers in the Korean market prefer and use the FASTECH's Ethernet products a lot. In addition, the most widespread software development environment in the world is PC, and Windows-based C++, C, C#, Visual Basic, LabVIEW, etc. can be used commonly. Thus, it has good versatility. Therefore, FASTECH Ethernet products provide a PI for these programming languages, making them ideal for various customers' software development environments. Like this, when configuring the machine, FASTECH's Ethernet products are used as a suitable solution in the Korean market that accessibility and versatility are important. Now, using actual machine as an example, I would like to introduce the concept of Ethernet product development. This machine aligns the lens and sensor of the camera module used in the smartphone. As you can see in the photo on the left, the customer applied 10 axis of Ezi-SERVO 2+E, which is standard type of closed-loop stepping system, and 5 axis of AC servo. When set the machine, there is a case that the machine requires AC servo motor, stepping motor, and I/O module at the same time. In the case of this 10-axis Ezi-SERVO, The customer can directly connect to a PC through the Ethernet port and control it using the Windows-based API provided by FASTECH. But, a separate motion board is required to control the 5-axis AC servo. The customer needs to configure two different software development environments to control Ezi-SERVO and AC-SERVO. This is cumbersome from the customer's point of view, and costs are increased by a separate motion board to control the 5-axis AC servo. In addition, long and thick bundles of wires connected from the AC servo to the motion board are required, and it makes the wiring complicated. In the next chapter, I will explain details with diagrams. As previously explained briefly, conventionally, a separate motion board was required to control the 5-axis of the AC servo, and wiring was complicated because many bundles of long wires had to be connected to the motion board through the servo interface cable of the AC servo drive. This inconvenience can be solved by using our product, Ezi-MOTIONLINK Plus E. Ezi-MOTIONLINK Plus E is an Ethernet Type 1-axis motion controller that can be used by plugging it into the interface connector of the AC servo drive. As you can see, for example, there is a Panasonic AC servo drive. MOTIONLINK can be directly attached to the servo interface connector of this Panasonic's AC servo drive. The servo interface connector of Panasonic AC servo drive is 3M50-pin connector, and most major AC servo drives also use this 3M50-pin connector. Since FASTECH's MOTIONLINK also uses this 3M50-pin connector, it is compatible with most major AC servo drives. However, the pin map may be different for each AC servo drive. For example, if the servo on signal of Yaskawa AC servo is number 5, Mitsubishi is assigned to number 7, but the function of the interface is the same. With this, you can remove the complicated wiring bundle from the AC servo to the motion board. By using Ezi-MOTIONLINK, a 1-axis motion controller, the customer can use 5-axis AC servo with only an Ethernet communication cable without a separate motion board. You can control these with the API that FASTECH provides. Also, I mentioned that two different software environments were required to control 10-axis of Ezi-SERVO and 5-axis of AC-SERVO. But, if the customer uses Ezi-MOTIONLINK, 5-axis AC servo can be used in the same Ethernet network and software environment using the API of Ezi-SERVO. In other words, a total of 15 axes can be operated with one program. I will show you a practical application example. This example applied total solution concept that stepping motor, AC servo motor and digital I/O module can be controlled with one Ethernet port, without separate motion controller. FASTECH's Ezi-SERVO 2 Plus E, which is stepping motor, Ezi-IO Ethernet DIO, which is digital I/O module, and AC servo are applied to this machine. As you can see, Ezi-MOTIONLINK, which is 1-axis motion controller for AC servo drive, is directly connected to a total of 8 axes of AC servos. Ezi-MOTIONLINK are connected by daisy chain using Ethernet ports, and they are also connected with Ezi-SERVO 2 Plus E and Ezi-IO Ethernet DIO of FASTECH by daisy chain through Ethernet communication. With simple wiring, AC servo and Ezi-SERVO can be driven by one Ethernet network at the same time. At this machine, I/O module is also connected. In the case of small machine like this, if you use Ezi-MOTIONLINK, you can control AC servo, stepping motor, I/O module with FASTECH's API. You don't need a separate motion board for AC servo. Just control with one Ethernet network. Therefore, it is possible to save the cost by removing unnecessary motion board and reducing wiring. To summarize the product concept, it is as follows. Since FASTECH basically provides Windows-based API for Ethernet products, customers can select development language like C++, C, C#, Visual Basic, LabVIEW, etc. for programming. In addition to the API, GUI software is also provided and can be downloaded for free from the FASTECH webpage. As you can see in the picture, Windows-based API and GUI software are used in all Ethernet products of FASTECH, including Ezi-SERVO 2 Plus E, a closed-loop stepping system product, Ezi-MOTIONLINK Plus E, a 1-axis motion controller for AC servo drive, Ezi-IO Ethernet DIO, a digital I/O module, Ezi-IO Ethernet AD and DA, an analog I/O module, Ezi-IO Ethernet CNT, a high-speed counter module, Ezi-SPEED Ethernet, a BLDC motor speed control system product, Ezi-POS Ethernet, a BLDC motor positioning system product, and Ezi-ROBO, a linear and rotary actuator system product. Thus, you can easily control FASTECH's all Ethernet products with Windows-based API via standard Ethernet port of PC. As mentioned earlier, FASTECH provides GUI software Ezi-Motion plus E and API for Windows free of charge. First of all, the GUI software can be downloaded for free from the website. If you access the following address and place the mouse pointer on the Download tab of the homepage, the item called Quick Download appears. Click on the item to display the product list. You can download the GUI software by clicking the Program button of the Ezi-IO Ethernet product series among the products in the list. You can also download the same software by clicking the Program button for other Ethernet products. And, in the path where Ezi-Motion plus E, FASTECH's Ethernet GUI, is installed, you can check the C#, C++, and LabVIEW example files in the example folder, and you can check the API in the include folder. For reference, 32-bit API of C# is in include folder, 64-bit API of C# is in include x64 folder, and 32-bit API of C++ is in include x86 CPP folder, and 64-bit API of C++ is in include x64 CPP folder. In summary, in the case of a single application, especially a small device, FASTECH's Ethernet products have built-in motion controller, so a motion board is unnecessary as described before. Using a standard Ethernet network, you can configure and control the entire machine through one Ethernet network, including stepping motors, servo motors, digital and analog I/O modules, and high-speed counter modules. This is the meaning of the total solution we aim for. From now on, let's check a demonstration video about how to control a stepping motor, an AC servo motor, digital and analog I/O modules, and a high-speed counter module together with one integrated GUI program. The products used in this demonstration are as follows. You can check 8 Ethernet products of FASTECH on the board list window. From the top, Ezi-SERVO 2 plus E, a closed-loop stepping system product, Ezi-MOTIONLINK plus E, and one-axis motion controller connected to AC servo drive of Yaskawa, Ezi-IO Ethernet DIO, digital I/O modules, Ezi-IO Ethernet ADDA, analog I/O modules, and Ezi-IO Ethernet CNT, a high-speed counter module. FASTECH's Ethernet products and an AC servo motor are easily controlled by PC-based GUI program via Ethernet network. Also, digital I/O modules, analog I/O modules, and a high-speed counter module are also controlled together by the GUI program. Lastly, with the demonstration video, I will show you that stepping motor and AC servo I/O module are controlled by one Ethernet network as in the previous application example. There are 28 axes of FASTECH Ethernet products, which is Ethernet standard type product of closed-loop stepping system, and 4 axes of AC servo. Total 32 axes of stepping motor and AC servo, and I/O module were controlled by one Ethernet network. The products used in this demonstration are as follows. By applying Ezi-MOTIONLINK to AC-SERVO such as Mitsubishi, Panasonic, Yaskawa, and Sanyo, a total 32 axis including Ezi-SERVO 2 plus E and AC-SERVO were controlled at the same time. As you can see, AC-SERVO and Ezi-SERVO are controlled by one network and program. There is no need for a separate motion board and can be operated simply with a PC. Until now, I've introduced FASTECH's Ethernet Total Solution. From now on, I will introduce Ezi-IO Ethernet CNT. First of all, I will explain the combination model name of Ezi-IO Ethernet CNT. In the example model name, I/O means input and output module, and EN means the product based on Ethernet network. CNT02 means that the product supports two high-speed counter channels, and E means that ECON connector is applied. Firstly, Ezi-IO Ethernet CNT is a two-channel high-speed counter module based on Ethernet network. As explained before, Windows-based API and GUI are provided for PC users. You can run multiple applications at the same time. With this, it is possible to monitor parameter values, I/O status, position values, speed values, etc. using our GUI program even when the customer's machine program is running. For example, you can check whether the limit sensor works properly during machine setting by running our GUI at the same time. If a problem occurs in the customer's machine program, it can be monitored by our GUI program, so it can also be used for debugging. Compared to the RS-485 communication type product, Ezi-IO RS-485, which was limited to 16 axes even at maximum, Ezi-IO Ethernet has 10 times faster communication response time, so you can see that the number of connectable axes has increased. Also, Ezi-IO Ethernet CNT supports phase difference pulse input method, 1 pulse and 2 pulse input method. I will explain each pulse input methods in detail. First, I will explain about pulse signal which Ezi-IO Ethernet CNT can count. Pulse signal is a signal in which high-level voltage and low-level voltage repeats as one cycle based on the set voltage. In case of Ezi-IO Ethernet CNT, high-level voltage is set as 5 volts or 24 volts and low-level voltage is set as 0 volts, depending on the input mode. One cycle of one output of high level and one output of low level is called one pulse. The part that voltage is converted from low level to high level is rising edge, and the part that voltage is converted from high level to low level is called falling edge. Then, let's check what phase differential pulse input is. Ezi-IO Ethernet CNT counts pulse input with A phase input and B phase input. All three pulse input methods counts the pulse input by using A phase input and B phase input. First pulse input method is phase differential pulse input. Phase differential pulse input means, two pulse inputs of square waves with identical frequencies but a 90-degree or 1/4 cycle phase difference. Ezi-IO Ethernet CNT can count by doubling or quadrupling phase differential pulse input. In case of quadrupling the phase differential pulse input, count is executed from the rising or falling edge of a phase and B phase signals. And, in case of doubling the phase differential pulse input, count is executed from the rising or falling edge of the A phase signal, and the B phase signal orders the count direction. In both cases, if the A phase signal precedes the B phase signal, in other words, if rising edge of A phase precedes the rising edge of B phase by 1/4 cycle, the counter value increases. And if the B phase signal precedes the A phase signal, the counter value decreases. Second pulse input method is one pulse input. In case of one pulse input, the count is executed from the rising edge of the A phase signal, and the B phase signal orders the count direction. If the B phase signal is high level, the counter value increases, and if the B phase signal is low level, the counter value decreases. Last pulse input method is two pulse input. In case of two pulse input, the counter value at the rising edge of the A phase signal increases, and the counter value at the rising edge of the B phase signal decreases. User can select the pulse input method among the three methods. Additionally, Ezi-IO Ethernet CNT provides latch, reset, preset, comparison output function. I will explain each functions in detail. First is counter value latch function. Latch function saves the counter value at the time when latch signal is input, to the latch value. Latch can be executed by inputting latch A, latch B and phase Z signal. You can save the latch values for each signals. Therefore, 3 counter values can be saved simultaneously. Second is counter value reset function. This function resets counter value to 0 when reset signal is input. Reset can be executed with the Ethernet command, external reset signal or phase Z signal. Third function is counter value preset function. This function changes the current counter value to previously set preset value through communication command. Last function is comparison output. This function outputs a signal when the counter value matches the comparison reference value. Ezi-IO Ethernet CNT provides 2 comparison output modes, periodic comparison mode and sequential comparison mode. I will explain about periodic comparison mode first. In case of periodic comparison mode, you can set first comparison reference value and output interval. The first comparison output signal occurs when the counter value matches the first comparison reference value. For example, when the first comparison reference value is set as 100 and output interval is set as 50, the output signal occurs for the first time when the counter values is 100, and occurs in every 50 intervals. Next, I will explain about the sequential comparison mode. In case of sequential comparison mode, output signal occurs according to 60 preset comparison reference values. For example, when the comparison reference values are set as 50, 80, 90, 120 and 200, comparison output signal occurs when the counter value matches the comparison reference values. Next, Ezi-IO Ethernet CNT can be connected to various external devices without special input setting because the counter input circuit of Ezi-IO Ethernet CNT supports both line driver output and NPN-PNP type of open collector output. In case of external device which support DC 5 volts line driver output, it can use DC 5 volts internal power supply of Ezi-IO Ethernet CNT or external DC 5 volts power supply as shown in the picture. And, in case of DC 24 volts NPN-PNP type open collector output external device, it can use DC 24 volts external power supply without any external resistor, as shown in the picture. In addition, Ezi-IO Ethernet CNT supports ECON connector type. ECON connector allows easy attachment and detachment of peripheral I/O devices such as PLC, sensor, encoder, motion controller and digital I/O module. Lastly, I will show you the demonstration video of high-speed counter module based on Ethernet network. The product names used in this demonstration are as follows. Ezi-IO Ethernet CNT counts the encoder value and displays the value on the GUI. You can see that the counted encoder value and the actual position value of the motor from the drive match. Until now, I've introduced high-speed counter module, Ezi-IO Ethernet CNT. On the FASTECH website www.fastech-motions.com, you can download product-related materials such as catalogs, manuals, drawings, and watch demonstration videos, and webinars. Also, if you search FASTECH on YouTube, you can see about more than 100 demonstration and webinar videos. Thank you for listening.